Hello, I'm JW, and we're not in the usual place today because the equipment we're going to look at doesn't fit in the house, and even if it did, I don't want it set up in there anyway. So here we are outside in the shed, and what we're going to be making is a CNC router. Now, a router is typically a woodworking tool, which is a motor on some kind of frame you can hold, and it has a revolving cutter. Here's an example cutter. This is a V shape, but many different shapes and styles are available. And the idea of it is it can either cut or shape or machine things into timber, plastics, or even metals as well in some cases. And we're making it computer controlled so that rather than doing it by hand, you can load an appropriate program into a computer, and then it will cut out and design and machine whatever part it is that you want. And you can get these in a variety of forms, ranging anything from the cheap Chinesey ones from AliExpress and the like, which literally cost a couple of $100s, all the way up to fully assembled and installed machines, which of course are into the many thousands, and in cases tens of thousands or even more. But of course we're not going to be going to either of those. We're going to do something in the middle, and we're going to be making most of it assembled from parts, apart from the mechanical assembly, which I've actually purchased ready assembled, mainly because I don't have any metalworking tools here. So although it's perfectly possible to get the mechanical parts and put them all together yourself, if you don't have any metalworking equipment, then that's extremely difficult. Now this table here contains most of the smaller components, and we'll have a look at some of these in a bit more detail. And the larger ones here, this is just a plastic pipe for dust extraction. This is one of these cyclone dust extracting things you can attach to a vacuum cleaner, therefore dust goes in a bucket. And of course all the rest of this is all related to it. So as you can see, there's quite a lot of stuff involved. Needless to say, it's not particularly cheap either. And the machine we're going to be building is not going to be at the cheap bottom end of the price range, but on the other hand it's going to be massively cheaper than if you went and bought an equivalent machine fully assembled. So let's have a look at some of the smaller parts then. Now for the electronic side of things, of course we're going to need a power supply, and we've got this power supply here. This one is made by Meanwell, so a decent quality one there. This actually outputs 24 volts. And of course 240 volts in the usual mains voltage in the UK. So 24 volts at 4.5 amps, and this will be for the control circuits. That's the terminals on the end, so not a huge amount of power required there. And for the actual motors and things, we're going to be needing this power supply. It's another one by Meanwell. This is considerably bigger, as you can see here. Let's remove it from the container. So that's the other one, and you can see on the side there that the mains voltage in again. This outputs 48 volts DC and up to 13 amps, so considerably larger and more powerful piece of equipment. Now these are not the cheapest power supplies in the world, but they are good quality ones, because obviously if you buy some cheap junk that blows up, it could easily destroy the rest of the equipment, so a bit of a false economy there. So 20 volts for the control and 48 for the actual motors. Now to join everything together, of course we're going to need some cable, and here's some cable here. This is what we're going to use for most of the wiring to the motors and the controls and so on. As you can see, there's a large roll of it here. This is CY cable, and if you look inside here you can see the inner construction. It's basically an outer plastic covering there, which is grey in this case. We've got this braid inside, so this is a fully screened cable, and inside the braid here we've got this sort of plasticky coating there. And then within that we've got the individual cores. Now this is actually 4 core plus an earth, so there's the earth in the green and yellow. And then we have 4 other cores, all of which are black in the case of this, but they are actually printed with a number. A bit difficult to see there, but it's just about visible on the side there. So it's just numbered 1, 2, 3 and 4. And so that's what we're going to use for most wiring. So of course there is a full roll of it here. And this particular one is fairly small. It's actually 0.5 square millimeters. But again, we're not talking about huge amounts of power. I'd say even the motors themselves individually don't actually use a vast amount of power when operating. We've also got some larger size of the similar cable, and that's here. This is a 3 core on earth, so it's exactly the same as this, but just with 3 cores and the earth. And that's actually going to be using for driving the motorised spindle, which is what does the cutting. This is a larger size because the spindle needs considerably more power to actually do the cutting through the material. Now talking the spindle, here it is. This is a Chinese one, and essentially what this is just basically an electric motor, and at the end here it's got a mounting screw here, and there's a collet in the end where you'd fit the cutting tool. So basically just rotates at a fairly high speed. Specifications here might be a bit difficult to get the reflection, but essentially it's a 2.2 kilowatt spindle, 80mm diameter outer casing, and maximum speed 24,000 RPM, although it says RMP on here for some inexplicable reason. But there it is at the end there, and you can change the collets to different sizes. Power goes in at the end there. It's a 3-phase deal, so it's 3 phases, and the other one is for the earth connection. Comes with this plug here to obviously attach to the top there, so cable goes in there, and that just connects onto the connection at the top. Now, so this is a Chinese one. Most of them generally are. You can get others which are not, but they cost a fortune. But nevertheless, this one is considerably cheaper and will probably do the job just as well. Now, the spindle being 3-phase, we'll need something to actually drive it, as we don't have 3-phase power here, and even if we did, it's not really appropriate just to shove the power straight on, because that would give you a single speed, which is next to useless. So what we're going to use is this device here. This is a inverter, so it's single phase in, 3-phase out, and this is a variable frequency, so it can adjust the speed of the spindle from pretty much nothing up to the full 24,000 RPM. Speed will depend on the cutting tools being used. And this again is a Chinese one. It came with the spindle as part of the set there, so it should obviously do the job. Fairly straightforward controls, just got the basics on the front there, a little knob to manually set things, although this will be fully automated, so won't be using that. And the other buttons there just for programming. The little front panel here does actually come out and can be mounted remotely if desired. Little fan in the top there, and obviously you can just about see through the side there. But basically, say it's 3 phases out, so it directly drives a spindle. And being variable frequency, you can get the full power of the motor over a wide range of speeds. Now, to actually move the mechanical assembly, as in the sort of X and Y direction and the Z as well, you'll need some motors. And the motors we're using are these stepper motors, so known because they don't rotate continuously, they just move around in very small pulses, and therefore can be used to accurately position things. These ones are NEMA 23, which refers to the basic physical dimensions of the faceplate, and we've got those because that's what happens to be the mechanical assembly which we have. And these are 8-wire motors, so maybe got 8 wires on the back. You can get some with 4 or 6, but 8 in this case gives you an option to wire them in a couple of different ways, but not desperately useful in this case. And you can see the specifications on the front there. Basically rate up to 4 Newton meters, and that's where they came from, and that's the rating and model number on the front there. So those are quite heavy things. They've got dual spindles as well, so a short one out the back, but again we only really need the one at the front in this case. 4 mounting holes for the bolts and whatever, and that's pretty much it. Now, the mechanicals we're using are a 3-axis machine, so it's X, Y and Z, but we're actually going to have 4 of these motors because one of the axes actually has twin drive, and again we'll be looking at that a bit later on. Now, stepper motors aren't just connected to the power and it runs, it needs to be controlled, so what we have here is a stepper motor controller, and these are made by Gecko Drive, as it says here. This is a model G201X, and essentially this connects to the motor and also some other equipment which we'll look at next. And we've got 4 of these, basically 1 for each of the motors, and these are considerably higher rating than the motors themselves, but that's fine because it's not desirable to run things at the full power. And so we've actually got 4 of these because obviously there's 4 motors, so 1 for each. And because these things tend to get fairly hot in operation, especially when used at moderate power, then we've actually got these, which are aluminium heat sinks, which will be mounting those onto. So basically it's flat on that side, and it will just be a question of mounting 2 of these on this one, and then we have another one which is identical to mount 2 of the others. In theory, we could just put them all on a long strip, but for mechanical reasons, it's more convenient to put these on 2, so we can have them one above the other, because that just happens to fit in the control cabinet rather better. Now, those stepper motor drivers obviously need to connect to something else, and this is typically called a breakout board or adapter board, and this is the one we're going to be using in this case. Now, this particular one came from Thailand. Now, this is called an MB2. So it comes from a place in Thailand for whatever reason, and essentially it's got all of these connections around the sides where you would connect, say, the motors and the various inputs and other things as well. And these are these sort of just press spring release things, so very easy to connect to. Now this board doesn't have any processing capability, and it doesn't have any way of directly connecting to a computer or other control system. Basically it's just a buffer, as it were, to optically isolate the things and give you a convenient access to the various connections that are on there. And in order to actually use this, this is designed to work with one of these. Now this is from Warp 9 Tech Design, and this is a motion controller, or in other words it connects between the computer and this device here. This is what actually does all of the processing. See the main processor on the middle inside there, and this actually is designed specifically for this breakout board. It actually mounts up here, and then we have some short wires which connect the various ports here together, so that is permanently mounted on the top. Now this thing runs at 5 volts, and of course we don't have a 5-volt power supply, but this board here runs on 24 volts, and it also contains on the board a 5-volt regulator and isolated supply, again specifically for this, so we don't need a separate 5-volt supply for that. And this thing is called a smooth stepper. This is the Ethernet version, in other words it connects using the Ethernet cable here. The Ethernet version is superior, mainly because it's using a dedicated connection, whereas unfortunately if you use USB it's shared with all kinds of other USB devices in the computer, which of course is not desirable for something which has to operate essentially in real time. Now in terms of other electrical components, we have this bag here which is full of all kinds of stuff. And what we've got in here, we've got some emergency stop buttons, so in case something goes horribly wrong and it goes out of control, you can cut the power using this or one of the others. And these are the press to disconnect, and then the twist there just to cause it to spring back into the correct position. And so we've got a couple of those, basically just the switch mounted in a orange housing. We also have this one, which is the same thing, but just the switch on its own. That's to mount into the control panel, so that just go on the front of that. Again, the same idea, really. And other stuff we have in here, we've got various couple of little fans there. And the rest of this bag is mainly things like these, which are switches. These are momentary switches, so they basically just press and don't actually latch in. These are also illuminated, and see they've got the 5 terminals there, 2 for the illumination and the other 3 for the switch. And we've got some different colours, most of these are white. So we've got a red one there, and then we've also got a green one in here, and there's a yellow one, and there's other colours, so a whole bag full of those. And for the rest of the control cabinet we also have this fan, which is a 24 volt DC again, so obviously matches the voltage of the other stuff. It says sleeve ball on it. What it really means is sleeve bearing, because this is just some cheap thing from China. Nevertheless does the job there, and just basically rotates around. Got some of these grills which have the foam filter inside, and I've actually got 3 of those because there's obviously an inlet and an outlet as well. And that's basically for the main control cabinet. Now we also have these things which are switches, and these are actually limit switches, so they go at the end of the mechanical travel, so when it gets or tries to go too far it will basically press the button in and send a signal to the controller that it's got to the end of the mechanical travel. And in theory it should never get to those, but in case it does you want it to obviously switch off, not just ram the motors into the end stops and possibly break things. So basically just click on and off, screws to mount down, and the cable comes out of the back there. And we've got 6 of these, so it's 2 for each axis, so of course you've got 2 ends of each axis, and there's 3 axes, so of course 6 of those. Now of course there will be a fair number of wires between the control cabinet and the rest of the equipment. So for the CY cable we put there, we've actually got these glands. Now these are not specifically designed for CY, these are just normal 20mm glands there, but the cable will fit through there, and we'll be attaching the braid internally in a different fashion because the specific CY glands tend to be very expensive and they're generally right faff to actually attach to the end. So a whole bag of these, but there's several other bags as well. Basically fit through a 20mm hole, the cable goes in the middle there, and you just tighten that down and it seals around the cable. And for the Ethernet connection between the board and the computer, we could of course just use an Ethernet cable and shove it through a hole in the cabinet. That's a bit kakaroo, so what we've got here, we've got 2 cables here, and we've got this fitting here which is actually a panel mounted socket, so basically we can just plug in one side, that goes in the panel through a round hole, and then of course it just plugs in the back, so it means we can disconnect the computer and remove it if necessary. And of course it's a whole lot neater than just shoving a big hole through and mashing the cable through there. So I've got then a couple of short cables there, obviously, to connect internally and externally. And because we want the power for everything to be switched via the cabinet, the computer and the monitor will also be switched through the cabinet. So what we've got here are a couple of short leads. This one goes in the computer or monitor, and then for the side of the cabinet, just got a panel socket there, and then that will just plug into that. These are also shielded sockets, so you see the shutters over the 2 pins there. So that will just go in the side of that. That will just go up to the computer directly above, and we can make our connections here on the back. And this means when we turn off the control cabinet, it will also turn off the computer and the monitor as well. Now for the cables that are actually on the moving parts, we have some of this, which is called cable chain, or sometimes energy chain. And essentially you put your cables inside here, and then as the things move, of course it keeps the cables in a nice tidy fashion, so they don't get all tangled up and twisted around moving parts, because of course that would cause things to be destroyed. So I've got several lengths of this. Comes in 1 meter lengths, but you can just unclip here and change it to whatever length you would like. And this does fit the CY cables we saw earlier, so of course ideal for that purpose. And for the rest of the cabinet, we've got various things here. We've got various plastic standoffs there to mount the board and various other components inside. Got a whole bag of these, which are self-adhesive little clips, so just stick that to the side of the cabinet inside there, and you can just fit the cables into those clips there to keep them in a tidy position. For the main switch, which will control everything, we've got this main switch in the box here. This is an interlocked switch, which means that it's the type that you can only turn on when the cabinet is actually closed. So essentially we've got the switching part here. This goes on the back wall of the cabinet, this goes on the front, and when you put this locking piece behind, along with this component, it means that you can't actually open the cabinet when it's in the on position. You've actually got to turn it to off, and then this piece slides out the back, and therefore you can only open it when it's in the off position. And we'll look at that in more detail when it gets fitted. And then we also have this thing, which is a contactor. Again, runs on 24 volts DC, so of course fits in with everything else. And this is what's going to be used to switch the main power, and of course make sure that it's emergency stops so things do actually work. And also if there's a power failure, when the power comes back on, it doesn't automatically power up and start destroying things. So fairly moderate sized contactor there. And so 24 volts, and this is actually a low power version, so it doesn't use huge amounts of power from the 24 volt DC power supply. Now this is the mechanical assembly, and so I purchased this ready assembled because it was just much easier and more convenient. Although say you could obviously buy all the things and bolt them together yourself. But so this came assembled as you see it here, and this is a 3-axis machine, meaning it can move in this direction, this can move across here, and then of course got the vertical movement here. And the motor or the spindle will actually attach to this plate. Cutter protrudes down the bottom here, then put the material, whatever it is you're cutting, on the bottom there. Now it also came with these bits of mounting hardware, which are to attach the stepper motors to the actual drive pieces there. Not too sure whether I'll keep using these or not. They're just basically screws that go through, and then you've got this sleeve which sort of gives the spacing between the motor and the actual frame, but nevertheless that's what it came with. And we've seen the motors already, and to attach the motors to the equipment here we've got some of these, which are motor couplers. So essentially that goes over the motor spindle, and the other end goes over the spindle on the actual machine as over here. So basically goes on there and then just clamps down with the 2 screws. And there's 4 motors, because so this, although it's a 3-axis machine, we have actually got 2 motors on the y-axis here, which is the longest one. Now in terms of size, this is a fairly large piece, and if we just measure the width here, the width between the 2 guides there, just over 29 inches or 74 centimetres. Length of the actual bed here is 43 on some inches, or approximately 110 centimetres. And of course we've got the height here, which is actually in the region of 120 millimetres, or the actual movement of the vertical piece is 120 millimetres. So it's a fairly large machine as these things go. Now just move the middle bit along here. This is where one of the motors will connect here. This essentially is the x-axis, which moves in this direction. And obviously if we just turn this, you can see that the carriage moves along there, or obviously goes back in the other direction. And so this axis only has a single motor. This is for the Z-axis, or Z-axis if you're American, and again if you just turn this it will move this plate up and down. And this is where the motor will attach with the cutting tool at the bottom. And then the other axis actually has two motors, one on each side, so there's actually one on the end here and one on the end far over there, and again that just moves in this direction. Here's a look at the Y-axis, or one side at least. So you've got the ball screw up here, the actual rail at the bottom, and then you've got the two bearings there underneath, and the other side of this is exactly the same. So again, we've got four bearings on each of the various axes, and the ball screw again goes right to the end there. It's just a standard bearing at the end there, and of course this end is where the motor will attach through that peg that goes through the outside. And even though this is twin drive, I can actually just turn this again literally with my finger, so you can see the thing will actually move there fairly easily. Of course it's designed to be driven at both sides simultaneously. Now here's just a look at the other axis here. So we've got the motor mount here, and as you see, we just turn that, it will just move the carriage along in whichever direction. The benefit of using these ball screws as opposed to just a normal threaded rod and a nut is that it's far easier for it to actually move. This has almost no resistance. I can actually just turn the end here just with my fingers, and then it will move it along, so far better. And these things have effectively zero backlash. Backlash is a property of any mechanical type of system, whereby if you've got a slight amount of play, say in the screws here, it can mean that this, if you turn it in one direction, when you go to move it the other way, there's a slight delay in it actually moving back. So obviously that's not desirable on this type of machine. And on the cheaper Acme screws, or whatever they're called, you can get nuts which attempt to prevent this, but this particular design has effectively zero. So if I turn it in each direction, you see it's moving pretty much instantaneously as I turn this, whereas if you had any backlash, you would turn it one way. When you went to turn the other way, this would actually turn slightly before the thing actually started to move, and of course that can lead to it being somewhat inaccurate when you're making cuts. And again, you can compensate for that in the software and so on, but of course far better to not have it in the first place. Now the X-axis here, you see, has the ball screw in the centre. It's got twin rails here, one at the top and the bottom, and if we just have a look over the top here, you can see we've got two bearings on the top, and of course there's also two on the bottom as well. So again, it's a four bearing type of arrangement. The Z-axis here, again, fairly similar. I've got the tubular rail here and the two bearings on this side, and again there's another two on the other side over there, and again the ball screw obviously in the centre there with the motor mounted on the top. And the front of the plate there, that's where the motor mount will attach, somewhere in the middle here, and then the spindle would go in, cutter down at the bottom. Now to control the equipment we're going to use a computer. Here's the keyboard and a mouse there, and the computer's actually on the top here. We have seen this in a previous video, so won't be going into that, but nevertheless it's fairly standard piece of equipment. And a mounted monitor on the front there. It's got a block of wood there at the moment because the computer will actually be screwed down to the top of the cabinet eventually, but at the moment it is just sitting up there. And the cabinet, which is all where the electronics and other equipment will be going, is this thing here. This is made of steel, fairly standard sort of thing you can get. Twist locks here. These are generally mounted the other way, so the door hinges sideways, but in this case, because we've got the restricted height available, it just happens it's easier to do it this way. So inside there, so it's just an empty cupboard, big holes in the end there, and they've got the gland plates which fit in those holes with the rubber seals. And at the back there, I've got a galvanised plate where stuff can be mounted, and so it's just sheet steel. It's got a sort of rubber seal around the edges, and the two twist locks here to hold the door shut. And the idea here is that we're going to have a air inlet at certainly one end, probably this end here, and then all of the cabling will come out of that end and of course go around to the machine on the table just here. So let's look there at the components, at least for the machine. And of course there's many other choices you could have made, so it doesn't necessarily mean that these are the best or the necessarily correct ones. So there's many different choices out there, but this happens to be what we've got, and that's what we're going to be working with. Now of course this is going to be a multiple part arrangement, so this time, say, just having a look at the components, And of course then we'll start actually putting the thing together in future episodes. And until then, thanks for watching.